Okay, thank you very much, Ravi, and that's going to be a challenge for me to keep the time as much as I was talking about that. Okay, so moving from parasite to viruses, obviously our favorite topic in my lab. Okay, I start with the thank you slide, and because as Cheyenne said, it's not me who is doing the research, but the wonderful people who are, and this is last year picture, what I'm showing to you. And also I want to acknowledge the funding agencies who over the years and currently are supporting our research. So over the years I worked with many different viruses, including I started with smallpox, working with ILTV, infectious bronchitis virus, a little bit with IBDV and Newcastle disease virus. My current research, or our current research, is focusing on fall adenoviruses with a different aspect of the virus and the disease caused by these viruses. I'm a virologist and a veterinarian, so we're looking at the viruses themselves, at their molecular nature, looking at the disease, the pathogenesis they cause. We try to diagnose the disease, and in addition, we are looking at how we can prevent the transmission of the virus, so develop vaccines against these viruses. So the current research around fall adenoviruses are the current projects. We are looking at the genomics of these viruses. We sequence many of the serotypes first in the world, and I'm going to show a brief example of that. We're looking at the pathogenesis of the disease, the inclusion body hepatitis, and importantly, we focused recently on shedding of this virus of the virus to the environment, and actually the interface and the influence of the immune response for virus shedding and the presence of the virus in different organs. About the molecular biology of viruses, we're looking at the function of different genes, how they contribute to the virulence of the virus and actually disease production, one by one removing them. Immunity to fall adenoviruses, that goes with collaboration with Cheyenne. And here we like to find a correlation between the ELISA titers and the VN titers, the virus neutralization titers. And if you want to hear more about this, my people are sitting at the back and they will be happy to answer any of those questions. Also looking at the mucosal immune response to these adenoviruses. Importantly, we are working on the development of fall adenoviruses as vaccine vectors and use to prevent other viral diseases and bacterial disease as well. Earlier, you heard Juan Carlos talking about our new project that we initiated on reoviruses. So fall adenoviruses, I don't have time too much to talk about that. Remember, the disease is caused by inclusion body hepatitis, important disease in Ontario, but because of some of the vaccination programs, what we have, we see fewer of the cases. I mentioned the genomics of these viruses. And well, of course, with the genomic analysis, the practical question what we have, can we pinpoint out the genetic changes, differences among the pathogenic and non-pathogenic viruses? And I know maybe somewhat you cannot read it, but what we found that on 3 proteins, the 33K, 22K, and 100K proteins, there are deletions on the non-pathogenic viruses. Of course, we have to do more genomic analysis to actually say that we can pinpoint the disease-causing nature of the virus due to these particular deletions. Now, okay. I'd like to show a few slides about our vector development. And first of all, we have infectious clone, and we have the FedMid system where we can easily manipulate actually. Dr. Pei can easily manipulate the system and the virus. So over the years and very recently, we identified 3 areas that can be deleted from the genome on the left end, deleting these open reading frames, and we can delete ORF19 in the middle, which is a lipase homologue, and we can delete these regions, and we can use these areas to insert foreign genes. So that's a basis for our vaccine development. And here you have a few of the advantages using actually adenovirus as a vaccine platform for many of our important diseases. And I'm going to show 2 slides with the kind of an application where we have, and I think this is a very important and one of our exciting news, that removing, as I mentioned here, the ORF19 at the right end of the genome, a so-called NetB cassette was inserted. Well, scientifically important, that's what orientation it goes. So what's this NetB? It's actually, this is a NetB toxin from Clostridium perfringens, and this is causing necrotic enteritis. So this is a kind of, it's a collaboration. The idea where we work with Dr. Prescott, whom you know is actually the expert in necrotic enteritis. And so what we have here is just this, that actually we have the recombinant virus, and the toxicity of this protein is shown by the cytopathic effect. So replicates quite well. So our next step here is actually hopefully take it to the chicken and see whether we can have protection against Clostridium. Okay, maybe the slides cannot be read at the back. What you see here is different polyvalent recombinant file adenoviruses. So with the different insertion sites, so we have opportunities to make polyvalent recombinant viruses. On the left hand, it is purple, is actually a gene coding for the hemagglutinin from an H5 virus. So it is an H5 hemagglutinin. And in this virus, we have the hemagglutinin neuraminidase gene from Newcastle disease. So in here, in another combination, we have H7 and H5 influenza viruses for 2 of the hemagglutinins important in influenza. And the last 2 where we have the HA from H7 at the left, which we have HN from NDV and HA from the H5 virus, but it says one insertion site, and here is actually showing the full potential where we have the HA, H7, HN from NDV, and HA from an H5 virus. And so this is a very exciting, and they replicate quite well, and we know how to administer these viruses. That could be given in the water, or we have to test actually some of the applicability of that. And the last slide, and I'm sure I used up all my time by now, my apologies, and that would be, why is not coming, the last but one slide. So we believe that actually these vectors will be a key tool in emergency management and improving poultry health. But how would we get there? It shows my philosophy, and I think how we should operate in a research environment. We do a basic research, develop products, maybe we test proof of concepts, and actually give this product to the industry for testing and further development. Okay, thank you very much for your attention. I think I used up my time. Thank you.